Good morning, students. Am I audible, visible? Hello. Please write in the chat box. Yes. So today we'll start new chapter, that is differentiability. Okay. रेस्पॉन्ड क्यों नहीं कर रहा है? So differentiability. So guys, I got a real valued function. A real valued function y is equal to f of x is said to be differentiable at x is equal to a real valued function y is equal to f of x is said to be differentiable at x is equal to a if limit extending towards a, if limit extending towards a f of x minus f of a upon x minus a exists. If value of this limit exists, then we can say that the function is differentiable at x is equal to a. Differentiable at x is equal to a means derivative of the function exists differentiable at x is equal to a implies derivative of the function exists, derivative of the function exists at x is equal to a. Derivative of the function exists at x is equal to a. If the limiting value of this expression f of x minus f of a upon x minus a exists at x is equal to a, then you can say that the function is differentiable at x is equal to a. So guys, all of you know, limit extending to a, limit of a function exists at a point only when its left hand limit exists and right hand limit exists. So, so this limit exists only when, write down the above limit exists when limit extending to a minus, that is left hand limit, limit extending towards a minus f of x minus f of a upon x minus a exists, and limit extending towards a plus f of x minus f of a upon x minus a exists, left hand, if left hand limit of the function exists, right hand limit of the function exists, and they are equal, then you can say that limit of the function exists, and limit extending towards a minus f of x minus f of a upon x minus a equals limit extending towards a plus f of x minus f of a exists. Okay. If both the limits, left hand limit exists, right hand limit exists, and they are equal, then we can say that limit of the function exists. This limit is known as the derivative of the function at x is equal to a. That can be denoted by f dash a. If this limit is the derivative of the function, then this limit will be left hand derivative, that is LSD, and this limit will be right hand derivative, that is RSD. So left hand derivative of a function f of x at x is equal to a equals to limit extending towards a f of x minus f of a upon x minus a, and right hand derivative at x is equal to a is equal to limit extending towards a plus f of x minus f of a upon x minus a. Okay. So guys, quickly note it down. I'll use the next page. Should I move forward? Okay. The next page. Page. କଣ ଯେମିତି ଅଛି ତ ଟିକେ ଷ୍ଟୁଡିଓ ଆସିଲୁ କି? ଆଉ ଏଇ କାଇଁ ପେଜ ନେକ୍ସଟ ପେଜ ନେଲେ ନଉନି? কিন্তু এই পটটাকে ଆଉ ନଉନି କିଛି। এটা কিন্তু এইপଟ ସାଇଡଟା କାଟିଦେଇକି ଏଇଟା ଚାଲୁଥିଲା ଯେ।
এটা ক্রস কলা পর হবো না।
ଓହୋ। hang ହେଇଯାଉଛି।
वहां पे आसुନି फोटो
मेसेज भी पढ़ी हेलानी।
अच्छा এটা করলে নো ব্ল্যাঙ্ক পেজ আছে फोटो
blank page ଆସୁନି। delete ମାରିଦବା।
रेवोल्यूशन से देखिए नेक्स्ट नेक्स्ट पे सर होतला बोलट
अजून सोडलं नाही काही। Limit extending towards a f of x minus f of a upon x minus a. This is the derivative of the function at x is equal to a. So left hand derivative at x is equal to LHD. LHD at x is equal to a. Left hand derivative at x is equal to a equals limit extending towards a minus f of x minus f of a upon x minus f a. All of you know how to find the left hand limit of a function. Since x are approaching to a from the left hand side, we can substitute x is equal to a minus h, where h is a very, very small positive number, and substitute x is equal to a minus h in the given function. So that will be limit extending towards 0 plus, normally it is written as limit extending towards 0, f of in place of x substitute a minus h, f of a minus h minus f of a upon a minus h minus of a. So plus a minus a cancels. So left hand derivative of the function at x is equal to a equals to limit extending towards a extending towards 0, f of a minus h minus f of a upon minus h. This is the left hand derivative. Note it down. Then right hand derivative at x is equal to a RHD right hand derivative at x is equal to a equals limit h tending towards 0, f of a plus h minus f of a upon h. This is the right hand derivative. Okay. So to test whether the given function is differentiable or not differentiable at x is equal to a, we have to separately calculate the left hand derivative of the function, right hand derivative of the function. If the left hand derivative exists, right hand derivative exists, and they are equal, then you can say that the function is differentiable. Otherwise, the function is a non-differentiable function. Right? Did you understand, guys? Did you understand? Please write in the chat box. Okay. So let's solve a couple of questions. आउथरे बुझेई दियंतु फास्ट ओके आउथरे फास्ट बुझेई दवा so function is differentiable at x is equal to a function is differentiable at x is equal to a if the limit that is limit extending towards a f of x minus f of a upon x minus a exists. If this limit exists, then we can say that the function is differentiable at x is equal to a and it is denoted by f dash a or a derivative of the function at x is equal to a. And all of you know that limit of a function at a given point exists only when its left hand limit exists, right hand limit exists, and they are equal. So left hand limit of this limit will be, if this is the derivative of the function, if this limit is the derivative of the function, then left hand limit of this will be left hand derivative, that is limit extending towards a minus f of x minus f of a upon x minus a is the left hand derivative. This limit is the derivative. Then left hand limit of this limit is called left hand derivative. So this is equal to, substitute x is equal to a minus h, limit extending towards 0, f of a minus h minus f of a upon a minus h minus a, that is minus h. This is the left hand derivative. And the right hand derivative is RSD. Right hand derivative is the right hand limit of this limit. This is equal to limit extending towards a plus, limit extending towards a plus f of x minus f of a upon x minus a. Now, since x is approaching to a from the right hand side, substitute x is equal to a plus h. X is approaching to a from right hand side means x is taking the values, those are slightly greater than a. So we can write limit extending towards 0, limit extending towards 0, f of a plus h minus f of a upon a plus h minus a, that is h. Right? These are the two important things you have to remember while solving or testing a function, differentiable or non-differentiable. Separately, we have to calculate its left-hand derivative, right-hand derivative. Then we have to check whether left-hand derivative, right-hand derivative exist or not. If at all they exist, then we have to check whether they are equal. If they are equal, then the function is called differentiable. If they are not equal, then the function is non-differentiable at x is equal to a. I hope it is clear to you. Shivani? Did you understand? Hello? Let me solve a couple of questions. Okay. So, write down a question. Test the differentiability of the function test the differentiability of the function f of x is equal to sine of mod x. Test the differentiability of the function f of x is sine of mod x at x is equal to 0. Test the differentiability of the function f of x is equal to sine of mod x at x is equal to 0. So come to the solution. First of all, we have to find out the left-hand derivative of the function at x is equal to 0. Then we have to calculate right-hand derivative at x is equal to 0. Then we have to check whether left-hand derivative is equal to right-hand derivative. So LSD, left-hand derivative at x is equal to 0 is limit extending towards 0, f of a minus h. What is a? A is 0. A is the given point. F of a minus f of 0 minus h minus f of 0, f of a upon minus h, right? This is equal to limit extending towards 0, f of minus h minus f of 0 upon minus h, right? So what is f of x? F of x is equal to sine of mod x. What will be f of minus h? F of minus h will be sine of mod of minus h. So this is equal to limit extending towards 0, limit extending towards 0, sine of mod of minus h minus f of 0 will be sine of mod 0. Mod 0 is 0, sine 0 is 0, that is 0 upon minus h, right? So all of you know, guys, mod of minus x is equal to x. This is equal to limit h tending towards 0 sin h upon h. You know, from standard formula of limit extending towards 0 sin x upon x is 1. So least limiting value is 1. Okay. Okay. Shruti is pretty good at mathematics. Okay, then RSD. RSD limit extending towards 0. F of 0 plus h minus f of 0 upon h. This is equal to limit h tending towards 0 sin of mod h minus sin of mod 0, sin 0, that is 0 upon h. Oh shit, this is minus h, this is minus h, so the value will be minus 1. Sorry guys, this is minus h, the left hand limit is left hand derivative is minus 1 upon h. This is equal to limit h tending towards 0 sin h upon h, sin h upon h is equal to 1. So here we find that left hand derivative exists, that is equal to minus 1. Right hand derivative exists and that is equal to 1, but they are not equal. So we can say that the function is non-differentiable at x is equal to 0. The function f of x is equal to sin of mod x is non-differentiable at x is equal to 0. Okay. Okay, exists. Left hand derivative exists, right hand derivative exists, but not equal to, but not equal. Here the left hand derivative is minus 1, right hand derivative is 1, hence they are not equal, hence the function is non-differentiable, right? Then next question. Next question is f of x is equal to, there's the differentiability of the function f of x is equal to mod of sin x at x is equal to pi. If the differentiability of the function f of x is equal to mod of sin x at x is equal to pi, right? So come to the solution. First, we'll calculate the left-hand derivative. LSD is equal to, what is A? A is equal to pi. LSD is equal to limit s tending towards 0, f of a minus s, that is f of pi minus s, minus f of a, that is f of pi, divided by minus h. This is the left-hand derivative. What is f of x? F of x is equal to mod of sin x. Mod of sin x, this is equal to limit h tending towards 0, mod of sin pi minus h, mod of sin pi minus h, minus mod of sin pi, minus mod of sin pi upon minus h, right? All of you know sin 100x minus theta is equal to sin theta. So this, and the value of sin pi is 0. So this is equal to limit h tending towards 0, sin of pi minus h, sin h mod upon minus h, right? When h is very, very small and h approaching to 0 from the right hand side, when x is very, very small and x approaching to 0 from the right hand side, sin x approaching to 0 from the right hand side, sin x is also very, very small and it is positive. You know, mod x is equal to x when x is greater or equal to 0. Mod x is redefined as mod x is equal to x if x greater or equal to 0. And mod x is equal to minus x if x is less than 0. So since here sin h is a positive quantity and mod of sin h will be sin h, this is equal to limit h tending towards 0, sin h upon h, sin h upon minus h. We can take minus outside of the limit. We can write it as minus of limit h tending towards 0, limit h tending towards 0, sin h upon h, sin h upon h is 1, this is equal to -1. I hope it is clear to you. Then we find that left-hand derivative exists and it is equal to -1. Then we'll calculate the right-hand derivative of the function at x is equal to pi. RSD. So quickly note it down, it guys. I'll use the next page. Okay. Then find the right-hand derivative at x is equal to pi. RSD, that is right-hand derivative at x is equal to pi for the function f of x is f of a plus h, that is f of pi plus h, minus f of a, that is f of pi, upon h. Okay. What is f of x? F of x is equal to mod of sin x. This is equal to limit h tending towards 0, sin of pi plus h, mod minus mod of sin pi is 0 upon h, right? This is equal to limit h tending towards 0. This is equal to limit h tending towards 0. Previous page, okay. Let me finish it first. Okay. So sin pi plus h is equal to minus sin h mod upon h. This is equal to limit h tending towards 0. Mod of minus sin h is sin h. So sin h upon sin h is 1. So sin h upon h is 1. Right hand derivative is 1. So first quickly note down this page. Then I will show you the previous page. Yes, not differentiable. Okay, next question. Test the differentiability of the function test the differentiability of the function test the differentiability of the function f of x is equal to x into mod x. Sorry. Test the differentiability of the function f of x is equal to x into mod x at x is equal to 0. Okay. So try to solve it. Take 2 minutes of time and solve it. Test the differentiability of the function f of x is equal to x into mod x at x is equal to 0. Tell me what is your answer? Differentiable or non-differentiable? LSD, RSD exist, but are they equal? Yes, equal. And okay. Come to the solution. LSD is equal to limit extending towards 0, f of 0 minus h minus f of 0 upon minus h. This is equal to limit extending towards 0. 0 minus h means minus h. Minus h into mod of minus h minus f of 0 is 0 upon minus h. Mod of minus h is h. This is equal to limit extending towards 0 minus of h square upon minus h. This is equal to limit extending towards 0. Minus minus cancels. H square upon h is h. Limit extending towards 0, h is equal to 0. So left hand derivative of the function exists and it is equal to 0. Then next calculate the right hand derivative. RSD. RSD is equal to limit extending towards 0. F of 0 plus h minus f of 0 upon h. This is equal to limit extending towards 0. Okay. H into mod of h minus 0 upon h. Mod of h is h. This is equal to limit extending towards 0. H square upon h. H square upon h is h. This is equal to limit extending towards 0. H. This is equal to 0. So here we find that left hand derivative exists, right hand derivative exists, and they are equal. Hence the function is differentiable. Function is differentiable at x is equal to 0. Function is differentiable at x is equal to 0. Okay. Next. Next question. Test the differentiability of the function f of x is equal to x square into sine of 1 by x x square into sine of 1 by x if x not equal to 0, 0, if x is equal to 0, at x is equal to 0. Then the differentiability of the function f of x is equal to x square into sine of 1 by x if x not equal to 0. 0 if x is equal to 0 at x is equal to 0. Tell me whether the given function is differentiable or not differentiable. First calculate the left hand derivative, then the right hand derivative, then check whether they are equal or unequal. No, since LSD RSD doesn't exist. Exist, beta. Exist. Okay. LSD. Left hand derivative at x is equal to 0. This is equal to limit extending towards 0. F of 0 minus h minus f of 0 upon minus h, right? This is equal to limit extending towards 0. F of minus h will be minus h whole square into sine of minus 1 by h minus f of 0 is 0 upon minus h. This is equal to limit extending towards 0. Limit extending towards 0. Minus h whole square is h square. Sine of minus theta is minus theta. Minus of h square into sine of, sorry, not minus, sine of 1 upon h divided by minus h. Minus minus cancels. H cancels. This is equal to limit extending towards 0. H into sine of 1 upon h. Okay. So this is function f of x, and this consider this one as g of x. The first function approaches to 0 and second function oscillates between minus 1 and 1. First function approaches to 0 and second function oscillates between minus 1 and 1. Hence the total function approaching to 0. Or you can use sandwich theorem. The sandwich theorem minus 1 less or equal to sine of 1 upon h less or equal to 1. Now multiply h to both sides. Minus h less or equal to h sine 1 upon h less or equal to h. Limit extending towards 0. Minus h is equal to 0. And limit extending towards 0. H is equal to 0. Hence by sandwich theorem, the intermediate function will approach to 0. Okay. This is one of the analysis. And second analysis is this function always approaching to 0. And this function oscillates between minus 1 and plus 1. So the total value will approach to 0. Hence the limiting value is 0. Did you understand, Shruti? I think it is clear to you. Okay. Then we have to find out the right hand derivative. RSD or right hand derivative. Right hand derivative is limit extending towards 0, f of 0 plus h minus f of 0 upon h. Right hand derivative is limit extending towards 0, f of 0 plus h minus f of 0 upon h. This is equal to limit extending towards 0, h square sine of 1 upon h minus f of 0 is 0. It is given in the function upon h. This is equal to limit extending towards 0, h into sine of 1 upon h, that is equal to 0. So left hand derivative exists, that is equal to 0. right hand derivative exists and equal to 0. Hence, left hand derivative is equal to right hand derivative. This implies the function is differentiable at x is equal to 0. Write down. The function is differentiable. Function is differentiable function is differentiable at x is equal to 0. Right? Okay. So is it clear to you? Yes. Next question. IG college means Indira Gandhi College. Manoj nahi ke ji? Okay. The next question. If f of x is equal to x square plus 3x plus 1, then find f dash 1. If f of x equal to x square plus 3x plus 1, then find f dash 1. Okay. What is the formula for f dash a? F dash a is equal to limit extending towards a, f of x minus f of a upon x minus a. F dash a equals limit extending towards a, f of x minus f of a upon x minus a. So f dash 1 is equal to limit extending towards 1, f of x is x square plus 3x plus 1 minus f of a. F of 1 will be 1 plus 3 plus 1, that is 5, divided by x minus 1. This is equal to limit extending towards 1, x square plus 3x minus 4 upon x minus 1. This is equal to limit extending towards 1, x square minus 1 plus 3x minus 3. Okay, because minus 1 plus minus 3 is minus 4 upon x minus 1. Now separate the limit into sum of two limits. This is equal to limit extending towards 1, x square minus 1 upon x minus 1 plus of limit extending towards 1, 3x minus 3, we can take 3 as common, 3 whole into x minus 1 upon x minus 1. In the second limit, x minus 1 cancels. So the second limiting value is 3. For the first limit, use the formula a square minus b square, that is equal to a plus b into a minus b. This is equal to limit extending towards 1, x minus 1 into x plus 1 upon x minus 1. The second limit is 3. X minus 1 cancels. When x approaching to 1, x plus 1 approaches to 2. 2 plus of 3. This is equal to 5. So f dash 1 is equal to 5. Got it? Is it clear to you? Write in the chat box. ଗଭର୍ଣ୍ଣମେଣ୍ଟ ଅଫିସରେ ଅଛି ତତେ କଲ୍ କରୁଛି। ହଁ ଅଫିସରେ ଅଛି କଲ୍ କରୁଛି ତତେ।
ଅଫିସ ଚାହା ଟିକେ ଧରିକି ଆସିବୁ। ଅଫିସ ଚାହା ଟିକେ ଧରିକି ଆସିବୁ ସାର୍ କହିବେ ସେ ଜାଗାରେ ଆସିବୁ ମ୍ୟାଥମେଟିକ୍ସ କ୍ଲାସ୍ ଆପଣ ପଠେଇ ଦେଇଛନ୍ତି।
Yes.
ତିରିଶ
Next question. If f of x is equal to x plus e raised to the power x, find f dash 0. If f of x is equal to x plus e raised to the power x, find f dash 0.
वर्कआउट बसी सर आप बहुत दिखाऊँ बहुत साइलेंट क्लास 6-7 नहीं होती नो
ଆପଣ plus 2 କୋଉ year?
13
13. ଏଇଠୁ ମୁଁ ପଢି ସାରିଲାଣି 15 ବର୍ଷ। ଦିଦି ମୋର ପୁରା renowned This is equal to limit extending towards 0, x plus e raised to the power x minus f of 0 is 1 upon x. This is equal to limit extending towards 0, x upon x plus limit extending towards 0, e raised to the power x minus 1 upon x. This is equal to 1 plus 1. 1 plus 1 is equal to 2. Okay. I hope it is clear to you. Then come to geometrical interpretation of differentiability. Geometrical interpretation geometrical interpretation of differentiability. Geometrical interpretation of differentiability. Okay. A function is differentiable. A function is differentiable at x is equal to a. A function is differentiable at x is equal to a implies that function is differentiable at x is equal to a implies that a unique tangent can be drawn to the graph of the function at x is equal to a. A function is differentiable at x is equal to a implies that a unique tangent can be drawn to the graph of the function at x is equal to a. Okay. So guys, all of you know what is a tangent is. Tangent is a line. Who can say what is the definition of tangent? Anybody? What is the definition of tangent? Most of the students say that if a line meets a curve at one point, then that is a tangent. But that is not the actual definition of tangent. The actual definition of tangent is limiting position of secant is called tangent. Note it down. Limiting position of secant is called a tangent. Okay, let me explain it through graphs. Suppose this is a curve, y is equal to f of x curve. Let P and Q be 2 points on the curve. Now join P with Q. Then PQ is called a chord or a secant. Okay. When Q comes to this position, again that second line will be another secant. Okay. When Q comes to this position, it will be another secant. When Q comes to this position, this will be another secant. When Q is very, very close to P, the second line will be tangent. Okay. So this is a curve. We can say that this line L is a tangent to this circle C. The line will be tangent if at the point of, in the small neighborhood of the point of contact, the direction of the curve and the direction of the line. In the small neighborhood of the point of contact, if the direction of the secant and the direction of the line remain same, then you can say that line L is a tangent. So if you take, this is suppose point P, this is point Q, PQ is a secant. When Q approaches to P, the second line approaches to the line PL, and the PL is the tangent. PL is the tangent. A function is differentiable at x is equal to a means a unique tangent can be drawn to the graph of the function at x is equal to a. So function is differentiable means left hand derivative exists, right hand derivative exists, and they are equal. This is suppose the curve y is equal to f of x. This is the point x. This is A. This is A plus h. This is A minus h. Okay. This is point P. Let it be point Q and this point be R. So coordinates of point P are A comma f of A. Coordinates of point Q are A plus h. F of A plus h. And coordinates of point R are A minus h. F of A minus h. Coordinates of point P are A comma f of A. Coordinates of Q are A plus h, f of A plus h. And coordinates of point R are f of A minus h, f of A minus h. The second line PQ, slope of PQ, M stands for slope. MPQ is equal to, slope is equal to y2 minus y1 upon x2 minus x1. MPQ is equal to f of A plus h minus f of A upon A plus h minus a, right? This is equal to a plus h minus f of a upon h, right? This is the slope of second line P2. When Q approaches to P, then this distance h approaches to 0. When Q approaches to P, then h approaches to 0. When Q approaches to P, the second line PQ will be a tangent. So slope of the tangent at P from right hand side, M PT, this is PT. M PT is equal to limit extending towards 0, f of a plus h minus f of a upon h. Okay, this is your right hand derivative. Slope of PT is the right hand derivative. This is equal to RHD, right? Sorry, not RH, RHD. Then join P with R. Slope of PR is equal to MPR. Slope of PR is equal to f of a minus h minus f of a upon a minus h minus a. Slope of PR is equal to f of a minus h minus f of a upon a minus h minus a. Plus a minus a cancels. This is equal to f of a minus h minus f of a upon minus h. When h approaching to 0, when q approaches to p, the second line PR approaches to the tangent line PT. R approaches to P means this distance h approaching to 0. So when R approaching to P, that is h approaches to 0, the second line approaching the tangent line PT. So MPT is equal to MPT from the left hand side. This is equal to limit extending towards 0, f of a minus h minus f of a upon minus h, which is your left hand derivative. If the left hand derivative is equal to slope of PT, right hand derivative is the slope of PT. This implies that a unique tangent can be drawn to the graph of the function at P. A unique tangent can be drawn to the graph of the function at P. I think it is clear to you. Let me know through the chat box. Is it clear to you, Shruti? Smita, okay. Okay. So write down two important note points. Then note point 1. If a function, if the graph of the function, if the graph of a function is curved, if the graph of a function takes a sharp turn, at x is equal to a, no unique tangent can be drawn to the curve No unique tangent can be drawn to the curve at x is equal to a. Hence, the function is non-differentiable. Hence, the function is non-differentiable. अभी खत्म हो जाएगा बेटा काजल और 5 मिनट रुको. If the graph of a function takes a sharp turn at x is equal to a, no unique tangent can be drawn to the graph to the curve at x is equal to a, hence the function is non-differentiable. No unique tangent means either two tangent exists or a vertical tangent to the curve exists. Either two tangent exists. For example, if you take the graph of the function f of x is equal to mod x, f of x is equal to mod x. You see, the graph of the function f of x is equal to mod x is like this. Okay, here at x is equal to 0, at x is equal to 0, no unique tangent can be drawn. In the right hand side of the, this is y is equal to x curve, this is y is equal to minus x curve. Okay, if you want to draw a tangent to the curve in the right side of x is equal to 0, then that will be the line itself, that is y is equal to x. In the left hand side of x is equal to 0, that will be the line y is equal to minus x. Here slope a is equal to 1, here slope m is equal to -1. So no unique tangent is drawn at x is equal to 0, hence the function is non-differentiable. In the first question that I was discussed in the class first question, that is sine of mod x. So without finding the LSD and RSD, if you want to able to draw the graph of this function, you can say that the function is non-differentiable. The graph of sine of mod x is like this. The graph of sine of mod x. Okay. So this function is differentiable everywhere except x is equal to 0. This function is differentiable everywhere except x is equal to 0. Okay. If you take the graph of the function f of x is equal to sine mod of sine x. F of x is equal to mod of sine x. The graph of the function is like this. This is 0, this is pi, this is 2 pi, this is 3 pi. This function is non-differentiable at all integral multiples of pi. This function is non-differentiable at all integral multiples of pi. Okay. If a vertical tangent exists, then also we can say that the function is non-differentiable at the given point. Okay, this is suppose what is the meaning of a vertical tangent? Let me explain you. Suppose this is the point P. This is point Q. Okay. So PQ is a second line. When Q approaches to P and Q is very, very close to P, the second line will approach the vertical line, that is y-axis. All of you know the slope of y-axis doesn't exist. Slope of y-axis doesn't exist. So if slope doesn't exist, then tangent doesn't exist. If tangent doesn't exist, then you can say that the function is non-differentiable. A function is differentiable means we can draw a unique tangent to the graph of the function at the given point. Did you understand? Let me know. Is it clear to you? Okay. So, guys, rest of the things we'll discuss in our next lecture. Okay. Have a good day.